Welcome to Chapter 3C. In this segment, we'll explore the State Comparison tab, your go-to tool for comparing uptake across different experimental conditions. You'll learn how to adjust views, zoom into regions of interest, and set significance thresholds to highlight meaningful differences. Let's take a look.
The State Comparison tab can be used to look at the statistical differences between two protein states. And it's displaying two different visualizations. On the left we have a volcano plot, on the right we have a woods plot. The volcano plot is simply the delta corrected deuteration versus the log of the p-value of the t-tests that are done individually between the set of peptides. So each dot on the volcano plot, each bar on the woods plot is a peptide t-test between the two states that we have selected, so the target state versus the control state. This view is viewable per time point. So for example, right now I'm just looking at the 25-second time point. And it's also per protein. If you had multiple proteins here, you would select different proteins from this drop-down menu. As before with other views, you can select the type of measurements that you'd like to see. Right now by default, I'm showing percent deuteration, but you can show the deuteration differences in Daltons as well. This view is really useful after processing, after let's say automated processing without any manual intervention, to look for and see if you can find any outliers, because very, let's say, obvious outliers might show up on this view without you having to scroll through the entire peptide table to find them. So for example, this peptide here doesn't look quite right in this data set. And we can check out its data, whether it's correct or not. But one thing you can do with outlier peptides is if you don't want to get into the weeds and check its data in every single state, you can actually simply remove them from the visualization by hitting the delete button. Hitting the delete button will then remove the peptide from the peptide table, and it'll also remove the peptide from any visualization that was showing that peptide. So now I've deleted an outlier peptide. There might be more, but for now I will not be cherry picking any additional peptides. This view is also customizable, that you can change the size of each view. You can also export each view by right-clicking and saving image. So for example, if I want to save the woods plot alone, I can just click Save Image, and I can change the width and height of the wood plot. So for example, if I want to make it narrower or not as tall, I can change that to be 2000 pixels by, let's say, 3000 pixels, 2000 by 3000, and I can also set the pixel density here. Everything on this view, not everything, but a lot of the properties of this view are customizable. So you can set a different font for your title and axes. You can set the font size for each of these. You can even change what region of the protein is displayed. So if I want to skip this region past 350, I can end the protein sequence here at 350. Same thing with the y-axis range. You can make it a little narrower. For example, if I want to see -20 to +20, I can change the view here. So these views are very customizable. And when I click Save, I can just save a TIFF image or a PNG or a JPEG, whatever you prefer, to your preferred location. As with the other views in Connect Studio, the way to zoom into an axis is to click and drag on the axis itself. So for example, to zoom in on this 0 to 50 region, I can just click on the axis and just click and drag, and that will zoom in on that region of interest. You can do the same on the y-axis as well. If you just drag, it'll zoom in. To zoom out, you can simply double click on each axis, and then it'll just reset the zoom level on each of the axes. So this is applicable for any view that has these type of axes. One thing that you can change on the state comparison view is the significance cutoffs. So you can see in the title here that the significance cutoff is considered to be 2.25% D at 95% confidence interval. This is set in the parameters here in this additional expansion. If the toolbar on your monitor doesn't fit and show all the options, you can always click this tiny arrow to show you the rest of the options that the toolbar has to offer. And to change the confidence intervals to say the 99 percentile, I can just change it to say 0.99 here. The 1 minus p threshold is now set to 0.99, and so you can see the significance cutoff is a little different. As well, you can define the standard deviation multiplier after the t-tests are done. You can apply, let's say, a 3 standard deviation multiplier to expand the region of significance to be a little higher threshold for significance. So the cutoffs for the volcano plot and the woods plot are completely customizable using these two parameters. The line sizes and volcano plot sizes themselves are also changeable. So if I change this to 15, then I've just increased the volcano plot point size. Same thing with the woods plot. I can change this to be a little thicker if I wanted to see my peptides a little easier. The error bars are shown by default, but you can turn them off. They're usually just shown for the significant peptides, but you can also enable them for the insignificant peptides. These error bars come from the MS2 deuteration measurements from DIA data. And sometimes, as you see here, they can seem to be floating in space a little bit. But that's just because the range that these error bars are showing is just a single standard deviation around the average of each peptide. And what can happen is that's just for the MS2 deuteration. And what can happen is if this peptide decides to use the MS1 deuteration, that value might differ a little bit from the MS2 data. That's why these significance bars sometimes can float outside of the expected place that you would normally find them. For example, in this peptide, it's clearly right in the center. But this peptide here, it might be using the MS1 deuteration. Regardless if they're floating or not, the important part is that they don't float into a region of non-significance. Like if this error bar was somewhere in here, I would definitely doubt that peptide's deuteration and whether it's real or whether it's an outlier. However, if the error bars are outside the peptide, but it's still in a region of significance, the rest of the peptides in the same region are showing the same data, there's not really a lot to doubt. No matter where you draw these significance cutoffs, that peptide has a significant change in its deuteration, so it's still something that needs to be paid attention to. The peptides that do cross the significant boundaries, let's say if a peptide MS1 deuteration is measured to be significant, but the MS2 deuteration is measured not to be significant, those peptides are usually considered ambiguous, and we have an option here to hide peptides with ambiguous error bars. There are some in this data set. You can see there are at least 3 peptides where the MS2 derived error bars for their deuteration do span and cross over the cutoffs for significance. So by default, these peptides are considered not significant, even though they might just be outside this range. So we cannot be certain that the measurements are precise enough to mark them significant, so we just assume they're not. Again, you can change that by toggling this checkbox over here on the toolbar.
That's how you compare experimental states and pinpoint significant differences in uptake. Next, in Chapter 3D, we'll introduce the heat map, a fast visual way to spot patterns and trends across all your peptides. Let's move on.